Hey everyone, Legend here. If you are building a machine for local AI, my job is to help you cut through the marketing specs and find the practical truth about what hardware actually works. For 3 years, the rule for running models at home was simple: buy an nvidia card. The general consensus was that CUDA was the only compute stack you could rely on to get models running without breaking your setup. This table compares the reality of July 2026. A 32GB GeForce RTX 5090 sells for $4,300. In the same shop, you can buy a 16GB Radeon RX 9070 XT for $670. That $3,630 gap is the premium you pay for the CUDA software stack. The advice to blindly pay that premium is officially outdated. And the reason you can save that money isn't because AMD suddenly fixed their AI software. It is because a gaming API got there first. The software that broke the CUDA monopoly was built to draw video games. So we must look at the numbers and ask, can a graphics API really outperform a compute stack AMD specifically wrote for its own silicon? Vulkan is an open-source, cross-platform graphics API, inside your phone, inside your Mac, and your desktop. For years, it has mostly ensured your screen draws windows and games properly. This chart measures token generation on AMD's newest RX 9070 XT GPU. A 500-token prompt through AMD's official ROCm stack manages 1,149 tokens a second. On the exact same card, the Vulkan backend hits 2,888 tokens a second. It's 2.5 times faster. To get ROCm working, you must navigate an SDK, check a tiny list of supported Linux distributions, and configure environment variables just to load libraries. Vulkan ships as a single zip file, and you already have the driver installed because your desktop needs it to function. Portability was always Vulkan's strong suit, but it historically lost on raw speed. That changed entirely when the Kronos group shipped the Cooperative Matrix extension. The open-source RADV driver took that extension and wired it directly to the WMA instructions, the dedicated matrix units AMD has been putting inside their RDNA gaming cards since 2022. A generic graphics driver reached the matrix cores on the silicon before AMD's AI team did. That single software connection eliminates the need to stay locked into NVIDIA's ecosystem. So why does AMD's official AI software perform so poorly compared to a gaming driver on its own hardware? The answer comes down to how a GPU schedules its threads. A GPU doesn't run one thread at a time. It runs a wavefront, which is a locked group of threads stepping through the exact same instruction together. Here is a visualization of how that works on AMD's data center chips. ROCm's kernel libraries were built and tuned for server hardware, which executes 64 threads per wavefront. But the consumer Radeon cards sitting on your desk, the RDNA architecture, have been hardwired to run 32 threads per wavefront since 2019. When ROCm runs on a gaming card, it still schedules work for 64 threads. Because the hardware only has 32 slots available, half of every instruction cycle expects work that simply isn't there. The processing cycle is entirely wasted. Vulkan and its RADV driver never carried that server history. They emit Wave32 kernels natively because they were built specifically for the hardware directly in front of them. You can read the bug reports from the llama.cpp tracker back in March 2026. Testing across multiple ROCm versions confirmed the exact same result: a 14 to 30% performance penalty in generation speed simply due to the wrong wave size. AMD is not shipping a slower graphics card. They are shipping a capable chip paired with a compute library written for a completely different shape of silicon. Vulkan secures the win here because it aligns perfectly with the hardware in your gaming PC, ignoring the data center configurations that bog down ROCm. Vulkan is incredibly fast, but we have to look at the workload where ROCm takes the lead right back: dense models. Look at this line chart mapping generation speed on a 27 billion parameter dense model. Across 5 benchmark runs, ROCm averages 34.6 tokens a second. Vulkan tops out at 28.1. Dense models are structured as one uniform matrix multiply after another. ROCm's hand-tuned HIP kernels are built precisely for that kind of predictable, continuous math. But the landscape changes when you load a mixture of experts model. Instead of reading every parameter, an MOE model jumps around in memory, selecting different active sets of weights for each specific token. This data visualization tracks the same hardware running a 35 billion parameter mixture of experts model. The results completely invert. Vulkan pushes 71.4 tokens a second. ROCm falls behind at 63.8. The cooperative matrix path handles that unpredictable memory jumping far better. This matters because in 2026, nearly every major model you actually want to run, Qwen, DeepSeek, Mixtral, has moved to the mixture of experts architecture. When you run local AI at home, you are limited by your memory bandwidth, not your math cores. MOE models read fewer weights per token, which translates directly to more tokens per second on consumer hardware. For the exact architectures that hobbyists and local builders download today, Vulkan provides the definitive fast path. ROCm retains an advantage in uniform server-style math, but Vulkan is perfectly optimized for the models dominating the open-source community right now. Tokens per second is a great benchmark, but it doesn't decide what you can run. The true bottleneck for local AI is entirely based on how much memory you can afford to put in the box. To find the real value, we have to reevaluate NVIDIA and AMD using the single most important metric in this space: price per gigabyte of VRAM. This bar chart maps out exactly what that memory costs you. A 5090 gives you 32 gigabytes for $4,300, which is $135 per gigabyte. A 9070 XT gives you 16 gigabytes for $670. That is $42 a gigabyte. AMD holds a 3-to-1 economic advantage. We see this advantage taken to the extreme with systems like AMD's Ryzen AI Max Plus 395. It puts 128 gigabytes of memory on one package, shared between the CPU and the integrated GPU. Over Vulkan, that desktop runs a massive 120 billion parameter model at 18 tokens a second. That is a small box sitting on a desk holding weights that no consumer NVIDIA card can hold at any price. The practical winner is the setup that lets you hold the smartest, most capable model in memory, not the one that processes a tiny model slightly faster. We have to acknowledge where the green team still leads. If you are looking purely at prompt processing, NVIDIA and CUDA are still ahead. A 5090 processes 14,000 tokens a second on prompts, while the same card on Vulkan reaches about 10,400. So here is the decision matrix. If you have an unlimited budget for 5090s, or you require an absolute zero-friction setup without touching a configuration menu, buy NVIDIA and stick with CUDA. Looking at this flowchart, the alternative is clear. If you are building on a practical budget and maximizing the size of the modern MOE models you can run, AMD hardware paired with the Vulkan backend is the winner. If you already own an AMD card, stop fighting with ROCm installations. Go to LM Studio or your terminal, download the Vulkan build, and run your models today. Legend here again with the bottom line. If you are buying hardware this month, price the memory, not the logo. The software lock is gone. Run these numbers on your own machine. Download the Vulkan builds, test your token generation speeds, and post your results down in the comments so we can keep tracking this shift together.